Hello and welcome to another episode of this city building tutorial in Unreal. Basically, today's episode is going to be about placing roads down, and where we end up is we're able to place a road tile down, and we're able to place adjacent tiles that eventually make a nice big road with an adaptive asset that kind of deletes pathways if there's an adjacent road, like at a junction. And it also means that we can't place tiles in invalid locations like right next to a junction here, but we can place them here. It's kind of another long video. Hopefully it is informative. I've tried to take it nice and slow so it's easy to follow, but please, if you do struggle, let me know. All feedback is really useful. And yeah, I hope this video is good for you. Let's get into it. So just before we get into the video, I do need to make a quick change to what I made last video. In the last video, we set up a grid cell and it kind of knows all its neighbors. I actually got this the wrong way around a little bit. Basically, south and west are the wrong way around and north and east are the wrong way around. So just before we start, you might want to quickly, if you followed last video, just plug in whatever you plugged into the north neighbor stuff into the east one and do the same the other way around, and then do the same for south and west. Sorry about that, that was a little oversight on my part. It's not too big of a deal, but it is something that will be slightly annoying if you're expecting it to be in a certain position and it's not. So I'm just quickly fixing it up. Okay, so now that that's fixed, I do actually want to just change some of the pre-existing functionality I've got. I want to go into my ploppable component and I want to change how it decides if I can put something down or not. Right now, the placement validity is done on overlapping actors, and actually what we want to do is we want to just call our grid manager and ask if the current cell is occupied, because that's what we did in the last episode. So to do that, we know the owner of the ploppable component. We're just going to get the actor of class, grid manager. So it just gets the grid manager that we've got spawned in the world. We're going to get the actor location. And we're going to call the function that we made last time, which was get closest grid cell. We're going to plug the actor location to the in position. I will tidy this up in a second. And based on the return grid, we can just do is occupied, because that's the function we set last time. So if this place is occupied, then our placement is not valid, so we want to do a not boolean on that. And plug that in instead. We can get rid of all this stuff. If we just move the update state back, put that in there, plug that in, pull this up here. Maybe move this back actually. Put that into that. And then hopefully I compile and save now. I get the same functionality as before. Yep, looks like I do. It's not spawning any because these spaces are occupied. Cool. Okay, so now what I'm going to do is I'm going to start making some actual objects that we can place down. So right now I've just got this generic building asset that has basically no functionality in it. I want to make something that is like a base class. So all of our other classes are going to inherit from this. We're just going to make it of type actor actually. And I'm just going to call this city builder placeable base asset. And this base asset is just going to contain all the logic that is going to be common across all the things that we can put in world. So I'm going to make this a pure virtual, and what that means basically is this particular actor cannot be used in world, but you can inherit from it. So I can create a child of this actor, and if you're not sure about inheritance in programming, I'd advise you look it up. It's quite common practice in the industry and it's not too difficult to get your head around, but the simplified version is this is a parent actor. There will be child actors that come off of it, and this particular parent cannot be spawned in world, only its children can. And to make a blueprint do this, you need to go to class settings in the editor view and then just click generate abstract class like that. Compile and save that. And then if I go to main game and I try and drag this into world, you see that nothing happens because I'm not allowed to do that because it's a pure virtual. And that's perfectly fine. That's exactly what we want. So I'm going to set some stuff up on here that means every child will have some common functionality. And all I'm going to do is I'm going to have one of the enums that we created in the last episode. So it's just like a building type enum. So if I go to the variable type, if I type in enum, building type enum, click on that, compile, save that. By default, it's just going to be a placed building. So that's fine. And then the other thing I want to add is a reference to the grid cell that this asset will be spawned on. Just so that it has access to its neighbors and stuff. That's some good useful information that we'll be able to get out. So let's just create an object reference to a grid cell, compile and save that. And we actually want to make both of these public so that the children have access to them too. And that's about all I need to do for this. The meat and potatoes is going to be in the children that come off of this object. And so yeah, let's start there. So the first one I'm going to make, which is kind of the point of this entire episode, is a road tile. So let's make this a type placeable base asset, like that. And this is going to be called CB road tile. And this will be our road. So here it is. First thing I'm going to do is just add a cube, so we've got some visual representation of it. I'm going to do some scaling of it actually. So if you make it 10 by 10 by 0.1, and then if I just move it up slightly, I've already created like a base material that's just, I've called it road material. It's basically just grey. There's nothing extra that I'm doing there, so don't feel like I'm missing out on you. I do need to actually, before I forget, I need to change the physics profile so it's a type building, and then our character controller is not going to collide with it because that would be a pain in the bum. And then in the event graph, in the begin plate, you can see it's calling the parent because this is inherited from a pure virtual. So I'm just going to drag this off. So once we've called begin play on our parent, we're going to come back into the child and we are going to set our building type. So that's the type that we made in the parent, and we're going to make it be a road because we know this is a road tile, so we know that's what we want. Okay, that's all the functionality we need for right now. This episode isn't going to go too much into like traffic and stuff. I just want to get my road tiles down and the surrounding areas, learn about it and are able to be built on. So I'm not going to be doing traffic this episode. That is really complicated logic that I will do in the future. So what I'm actually going to do is go back into my player controller. If you remember, this is where I update and I spawn all the buildings and stuff. What I want to do is this placeable actor, I want to change this type now to our new one. So we put in our new placeable base asset. I want to make sure that we're always using a placeable base asset when I spawn a building. You'll see that it's not compiling properly because there's some certain stuff that's gone. And that's probably because this placeable actor type can be an actor. So I'm just going to make sure that this is a placeable base asset class reference as well. So change that variable type. This again will probably break because this building asset is not the correct type. So let's just change that to our road tile. Compile that. We've still got an error. Here we go. It's just in here. So if we just drag that into there and we need to drag a new one, and we actually need to cast this now to a placeable. Cast to a placeable of that. Plug that in. Then as a placeable actor, plug that in. And if the cast fails, we know something is not right. That shouldn't actually fail because we've now changed this placeable actor type. I am actually just going to throw up an error. If this comes through, just so we know. So we'll say actor of non-placeable building type detected in set placement mode enabled. And then that will tell us if something's going wrong. So let's plug that back into there, and then let's plug that into there, and we can just replace this now. So just clean this up, move that down there, move this over here. And actually, just before I forget, I need to drag that into there as well. Compile, save that. Another thing I need to do, when I spawn the actual building, what I want to do is I want to now tell the building that what its occupied grid cell is. So in this spawn actor, I can pull this out. I first need to cast this to be our placeable asset, just so you know it's certain that it's definitely that. If I plug that in there, and then as this placeable asset, I'm gonna set a grid cell reference, and the reference to set is the closest grid cell, so I can plug that straight in. And then the other thing I need to do, I'm actually going to move this around a little bit, so I'm going to do this stuff before I do the set occupy. And so I'll just plug that into there, and that into there. Break that link like that. And what I want to do is, as the placeable base asset, I need to get the building type, and that is now what I want to plug into there, like so. Okay, now our building that we're putting down knows what our grid cell is, and our grid cell knows what our building is, and it knows the type and everything, so they can communicate a little bit, which will be useful for some logic I want to do later on. Okay, let's just double check that this all works. You can see my road asset. I can place them down on cells that are unoccupied. I can't place them on cells that are currently occupied. You can see from the list on the right that there are no more being spawned. I can place them there, and that spawns, and so on and so forth. Okay, so that's really good. A quick example of why I want the grid cell and the buildings to know about each other. If I build a road here, oh, I can't place one there for some reason. I'll place it there. And now I can. Okay, so there's a bug somewhere. I'll do some digging into that later on. But basically, if I have a four-way junction here, what I'm going to do is, I want to be able to build on the side of these roads, but the way I'm planning on having this made is I don't want to be able to build a road on these 4 squares that surround the junction, because that's going to make the junction too large. That's going to cause all kinds of traffic problems and AI pathing issues when I get further down the line. So I actually want to do a check as part of my ploppable component. If this is a type of road, and like the diagonal tile is also a road, then we shouldn't be able to place a road tile here. If that makes some kind of sense. So we need to check, if our north and east neighbors are occupied, then make sure our northeast neighbor isn't occupied. Similarly with north and west and south and east. So we need to do that check for all the corners. So let's jump into that. Okay, so let's go back into our ploppable component, and I'm going to create a new function. I'm going to create a new function that's going to be our road placeable check. And what this is going to do is just going to update our isPlacementValid based on whether this is a road and the certain checks come back. So I'm first going to need to get my owner, and I'm going to cast this to the placeable type we made. So do that as so, compile it, and then if this cast fails, then we'll just return. That's fine. But as the base asset, we need to just do a get building type, and if this equals if this is a type of road, then we want to run the logic, and if not, we'll just return. So we'll do another branch. Plug that into there. If this returns false, we'll just come out. But if it goes true, then we'll actually run some logic. So let's get our base asset, And then we need to get the grid cell reference. And we just need to check the neighbors. So let's pull this out and we'll say get north neighbor. We're going to need to get every single one, so we could pull them all out now, just for ease. So that's the south, get west, and get east. All right, so let's compile, save that. Right, this is where the logic gets a bit messy. So we're going to try and do this as neat as possible. So to begin with, let's just see if each one is a type of road. So if we just get out the occupying type for each one, and then if we say, is this equal to a road? I'm just going to copy and paste this a few times. Spread it out a little bit more. Blueprints can get very messy very quickly. Just plug these in. Like so. And then from this, we know which ones we need to check. So we only want to check the ones that return true here. So what we want to do here is, there's only certain things we want to check. I'm actually going to swap these around, the south and the west around, just so our blueprint ends up looking a little bit neater in the end. So we can basically make it a bit neater by just targeting the north and the south first. So to do that, I'm just going to do two and booleans. So if the north is a road and the west is a road, then we have a branch here. And let's just label this northwest. Similarly, if north and east, so do the AND gates and then plug east in. Pull another branch, and that is northeast. Move that up, and then with this, I would do the same with the south. So there's only 4 logic gates we actually need. So it's not horrendous, but it does get messy very quickly. And that one is southeast. And the last one is going to be southwest. Just make sure that's right. Ranch and southwest. Cool. Let's pull these down here. Okay, we kind of got this big messy spider web, but we'll try and keep it neat as we go forward. Okay, so let's get into it then. So what I'm going to do for the northwest and northeast, I'm just going to pull off the neighbor north grid cell, and I'm just, to begin with, I'm going to say get west, get neighbor west. Put that there, and then what I'm actually going to do is just double click on this line here so that I have a nice reference to the north neighbor, and it kind of neatens things up. So I actually want to first check if this west neighbor is even valid at the moment. You can actually, instead of pulling out the boolean, there's already a function made here, so we might as well just use that. So the true will go into let's just check that the neighbor is actually valid, and if we're not valid, then we can skip on to the northeast check. Again, I'm just going to double click on my blueprint strings and just neaten these up a touch. So they're a bit more readable. If the neighbor west is valid, then we just want to do a gets occupying type on this. And again, very simply, let's just check if this is a road. If this is a type road, branch. So if this is true, so if we trace this all the way back, so we have a north neighbor and we know our north neighbor's type road. If our west neighbor is also a type road, and from that we figured out that our northwest neighbor is of type road, then our is placement valid needs to be set to false. So that is set to false. And then what we want to do is we just want to add a return node to this function here. Because we want to, this is called earlying out. So if we know that we don't need to run any more logic because we've gotten to the point that we know this placement is not valid, we can just simply return out, and then that skips the rest of the logic and saves on a bit of time, and it's saved on a bit of CPU time, so it makes our program a little bit more optimized. So that's why we add that there. And that is basically the logic. So I will just extend this comment all the way out. So that's kind of all encompassing. And we just need to do this for each one. I understand that it's a little bit tedious, but it's just the way it has to go for this logic, unfortunately. If you think of a better way, please drop a comment below to make this a bit more efficient, and feel free to incorporate a bit more efficiency in your programs too. The only reason I'm doing it like this really is because I'm a C++ programmer and blueprints always look horrible to me anyway. I try and be efficient if I can, but I'm running this is going to be such a low intensity game that it doesn't really matter here. I'm just trying to teach you guys how to make a city building game. I'm not trying to teach you how to program necessarily. So yeah, let's carry on. Just do another is valid. I'll probably skip ahead in the video. And what I can actually do is I could probably just copy and paste, to be honest. That might actually be better. So if I just copy paste that in, got a return there. The one thing I do actually just need to remember if this condition returns false, just make sure you plug back into this node here that I've created, and then that will continue the flow down to the next line. And what I can do now is I can literally just highlight all of this, copy that, paste it in here, just hook up the actual connectors. So that's neighbor west, that's good. So let's do it again. Just paste that in, and just to speed things up a little bit. And then just double check that this is neighbor east rather than that neighbor. So this is the south that we want. Plug that into there. Again, double click, bring this down a little bit, and then get neighbor east. Plug that into the input object. Plug that into here. Delete the west. Hook all this up. Bring this down here. And then bring this all the way over. And then just make sure we're continuing the flow all the way down. So if this is false, we continue down the path. If this is false, we continue down the path. If this is false, we continue down the path. This isn't valid, we continue down the path. And again, just for neatness, let's just do this. Actually plug that false into there. Similarly here, let's just make it a bit neater. Plug that into there. And then plug this into this one. I'll plug this into this one. I think that's everything looking good. What I have actually just noticed is that needs to be unticked. We want to set it as false, not true, because the placement is not valid. Make sure you don't do that. Right, and then we actually just need to connect up this branch. So if we're a road, if this is true, then let's start with northwest. Again, just to make things neater. Okay, and then the last thing you need to make sure to do is in the update state, when we set, this is going to have to take place after the is placement valid set. So let's just drag this back a little. And then after this, we're just going to do a road placeable check. Because it might just return out, and if it does, we'll just keep the value that we've set here. And now if I run my main game, hopefully this is going to work first time. Click here, click here, click here. Not letting me click here and here. Does still let me click there. So this should be northwest that is blocking it. So let's go back into here and just double check what's going on. So let's toggle breakpoint in here. So the current condition is false. Okay, so I'm going to actually just toggle breakpoint here, so when we're actually on the right tile. So I did a little check and I did actually get some errors. The problem here is our target doesn't actually have a grid cell reference yet because it hasn't been placed down, which of course, so I completely forgot about that. So we're just going to create a new input, and this is going to be a type grid cell. It's just going to be an object reference. We'll call this in grid cell. Compile, save that, and that is just going to, and that's actually what we're going to use in here. So I can delete this. If I just pull this down, plug those in, like so. And then just be sure to go back to wherever you've called this function from. So in update state, the road placeable check, use this grid cell as the in, like that. And now, hopefully, if I just create a little trifecta here. So I've created a four-way junction. I know it's not very visible, I do apologize about that. And hopefully it stops, I'm not allowed to place a road there, that's good. I'm not allowed to place a road there, that's also good. Can't place a road there, can't place a road there. Can I do it there? Yep. Can I put it there? Yep. 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 Oh, and not there, not there. Perfect. Okay. That's actually really good. That's exactly what I want. Obviously, sorry that these roads aren't too visible at the moment. I'll update those in a second just so we can get a bit more visual representation. So there is a bit of a bug somewhere in that when you first hover over this, it doesn't instantly turn red. So that might be an issue going forward, but we'll go into some debugging at some point and figure all of that out. I'm getting some errors in the probable component, specifically in this function that we've just made. If we go down to click to where it is, so this branch is failing. If I show the message log, it shows me that the neighbor north property is bust. So that is probably what the bug we're getting is. So it's basically saying that the target that we've got, this neighbor north, is actually a null reference. It doesn't have an object. That's the problem there. So similarly to how we did these is valids on the neighbors west and east, we need to actually run these on all four of these to get rid of those errors. So we can do that actually, and it's definitely worth doing. Actually, if I do an is valid, I'm just going to get the boolean out this time. And then similarly for the west, I'm just going to do another is valid like that. And we're going to do something very similar to here. So we're just going to do an and. So we need both of these to return true. Again, another branch. And we can just hijack that, put that into there. That needs to be true to run this. We need east to be valid to run the next check. So similar, another and. Put that in. This is where blueprints get very, very messy. And it's a real bugbear of mine. I hate having messy things just absolutely everywhere. So let's pull those out a little. So I'm actually just going to comment these to try and make it a little bit better. So that can be a comment on the northeast, northwest, southeast, southwest checks. And then in here. I've actually got that missing. That can be dragged back in there. That can be dragged back in there. That can be dragged back in here. And then, sorry, let's just pull those in, make them a bit closer to the action, like that. And then what I can actually do is this, if I pull this down, I can just drag this into this branch instead. True will continue through. If false, we'll start on the next one, which is southwest. So it's just this, another and, boolean. And you can see there's strings all over the place and I absolutely hate it. But that's the price you pay with blueprints, unfortunately. And we just kind of have to crack on. So pull that into there. Oh, missed apparently. Pull that into there. That into there. Forgot to do the false, so the false would just attach to that. Similar there. Similar there. And then the last one to check is over this one. Do the and. Plug south in. Oh, I've actually made that one wrong. Just catch that before it goes wrong. An is valid check. Pull that across. Plug in. Like that. Try and straighten these up just a little bit. I'm going to put one to each side just so that the strings are a little bit more manageable. Plug that there, and then another. This is why I comment everything, just to neaten things up and make things a little less horrible to look at, even though it's still pretty horrible to look at. Move this further down, bring the comment down, actually add in the branch that's needed, and plug that into there. This goes into here now, and then the false doesn't do anything. The false will just return. Hopefully now when I run, see if I get any errors. Right, no more errors. The errors have disappeared, so that's really good. Yeah, so this is what it looks like all in. How horrible does that look? That is blueprints. Go through the video very slowly if I've gone a bit too quick there, and please leave feedback if I'm going too fast for some of you. I don't want to be like a lot of other online programming tutorials where they literally just fly through everything and you don't have a chance to even take a breath. So let me know if I'm falling into that trap. It'd be really beneficial. Not just for me, but for you as well, if you're watching these videos. Right, one last bug to fix. So as I mentioned before, if I place these three down, currently I can place this down, and I have to go off to another tile and then come back for it to become invalid. I actually found what that was. If you go into the ploppable component and to the event graph, you can see that although we changed the functionality earlier to stop the on overlap being tied to our update state, that is now actually no longer valid because we're not using overlaps. So we actually want to do the tick event, which means we'll be doing a check on this whenever our poppable component. Oh, sorry, and let's just delete those. We'll start with an update state as well. Because we don't actually need the overlap stuff anymore. We just want to update. So now if I hit play, I do it straight away. And that's what the problem was. So just a little bit of debugging to find that, but there we go. Okay, cool. So now I'm actually going to do just some cosmetic stuff to make our road tiles look a bit nicer. I'm going to just create some more cubes, and these are just going to be pathways, essentially. I'm actually going to set the scale of that to 8 across, and then probably 2 wide like that. And I'm going to bring this all the way over to this edge, like that. And there's going to be a bit of clipping because it's Unreal. And I'm just going to move this up so it sits nicely on top. you'll see there's a tiny little gap. Unreal does like to this. So let's see if 75 is correct. That doesn't seem to be. Yeah, okay, 75 is sitting on top of it perfectly. Actually, that's going to change because I need to change that to be a lower amount. So if I bring this back down, so probably going to be 30. 30, there we go. And let's just make a quick pathway material that's orange. So back to the main game, go to contents, materials. I'm just going to duplicate my road material, call this pathway material. Double click on that, and then let's just make it like a nice, or like maybe it needs to be a bit darker than that. Okay, how about a nice yellowy color? Save that. Let's go back to the road tile, make the pathway material. Okay, save that, and well, I'm actually going to, I think this is a bit too wide, so I'm going to change that back down to 1. Bring this all the way back to the edge. Okay. Let's call this pathway. In fact, I'm going to call this pathway east because X as our forward is north. That's how I'm aiming for this to work. So if I drag it that way, that is actually north. So this is going to be our east pathway. I'm going to duplicate it to make west, north, and south. And why I'm leaving gaps in the corners will become apparent momentarily. So that's minus 450. That needs to be west. Copy paste that. Go back to the middle. Move that by minus 450. And then rotate it by 90. And that is pathway south. Again, I can't spell south. Let's just duplicate that. This will be pathway north. And then I'm going to put that to positive 450. Cool. And then I'm actually just going to duplicate these, scale that back down to 1, and this should fit nice and snug in our corner. Perfect. So this can be southwest. Once again, let's highlight all of these and just make sure we turn off the collisions for them like that, and then they won't interfere with anything. They won't interfere with the character controller when I put them down. So the idea here is if there's 2 roads connected here, I'm going to remove this pathway so that it looks like a road. So let's get onto that. So the corners will always be there. They'll never disappear. But these inner ones where the roads can connect, that's where I'm actually going to make them invisible depending on their neighbours. And to make this efficient, and it's because it's something I'm going to do in the future anyway, I'm just going to create a roads folder. And I'm going to add a road manager in here. So this is just going to be an actor that I can place in world, similar to the grid manager that I've already made. So this will be just a road manager. Make sure I automatically drag an instance into there. Let's just open this up. This is just going to store a list of all the roads. Road array, so road tiles array. And that's just going to store every single road tile we have in the game at the moment. And so if we create an event, we need to make a custom event, and it's going to be add a road tile, and it's going to take in the new road tile that's just been made. So road tile object reference, we'll call that new road tile. We actually just need to make this an array like that. Pull this out, and then we're just going to add in the road tile that we pass into the function. Like that. Then let's just make sure that runs. That's cool. And what I do want to add in as well in our road tile, let's just create a new custom event in here. And custom event, and this will be on new road tile added. This will basically be called from the road manager, and this will tell us to, hey, let's update all our pathways, just because all of our neighbors have probably just been updated, so we only want to do the pathway checks when this comes in. If we were to do this logic I'm about to do in the event tick, it'd be way unoptimized, and it would call every frame, and it would just take up a bunch of CPU time that we don't want to do. So before we dive into this, so we don't forget, when we add a new road tile, so when we've done this, what we want to do is we want to do a for each loop, and we just want to simply call on each individual one the event that we've just made. So on new road tile added. And then they can all update themselves, and if we want to do any future logic, because these road tiles are going to get super complicated eventually, because we're going to have to add pathfinding to them and stuff. So we can just use this on new road tile added to update any of that. But for now, all we really need to do is we need to get our grid cell reference like that. And we need to do checks on our north, south, east, and west neighbors to see if they're roads. So let's start with the north. So very similar to the last one, this is going to be quite messy. So what I'm actually going to do is just add another function quickly that is just going to be update side of road tile. And it's going to take in a neighbor, so that'd be a grid cell. So that'd be a grid cell ref. And that is going to be a type grid cell. And let's just compile and save that. It's also going to take in a reference to a static mesh, which is going to be our pathway. And that's just going to be a static mesh. Let's just be an object reference. So all you want to do in here is we're just going to say, first we're going to do an isValid check. And then we're going to say if this is valid, and if the occupying type is a road. So if that equals a road, just do that, and then set that to road. If this is true, and then what we need to do, I think I've actually done that right, that needs to be a static mesh component, and object reference to that. I just go quick compile and save that. And then we can call set visibility on that. Sorry, let's just neaten this up again. So if this is all true, so if the target above us is a road and is valid, then we actually want to set the visibility to false. And then in the case of anything else, we want to set the visibility to be true. If we compile and save that, and then just make sure to drag that into there, compile and save that. Go back to our event graph, and then this is why I've added in that in. So I can actually just call an update side of the road tile. I can plug the north neighbor in and it'll do the check for me, and then the pathway will be the north pathway. I can plug that in, and then I can basically just duplicate this 3 more times, and then just make sure I put the right things in. And that way, you know, our logic is still as messy, but it's contained within here. So if I just do this for each individual neighbor type, and then I can do the same for the correct pathway it should correlate to. Okay, link all these up like that. File save, and then just want to make sure we actually do call this. And then the last thing to do is make sure we call this add road tile. So if we go back to our play controller, we just need to make sure we call that road manager if we just need to call this add road tile function. So sorry, that's the wrong page. What we can actually do is just pull out our spawned actor, and if we cast to a road tile, if this cast succeeds, then we know we should add it to our manager. So let's just, if this is okay, then we're going to do a get actor of class, and that's going to be our road manager. And then from that, we're just going to do a add road tile and plug in the casted tile. I'm just going to comment all this just so I can find it easier in the future. Notify road manager of new tile. Compile, save that. And now let's see if this has actually worked. So I'll place a tile down there. It's got all its pathways. If I do one above it, you can see the north and south disappear. So now I'm actually getting some kind of road system. Look at that. I'm not an artist, so this doesn't actually look particularly good. I will spruce it up in the future. But we basically have a road system. Right, so thank you for watching. Again, this was another long video, so thanks for sticking with it if you did. Hopefully you can see where we're trying to get to in the end. And now we're going to actually start making some real good progress on our city. So if you have any questions or anything, please drop a comment below. If you need me to go into anything in more detail, just do the same. I hope you enjoyed the episode, and let me know what you want to start seeing in the future. I'm probably going to start doing buildings and stuff now in the next couple of episodes. So yeah, thanks again for watching, and I hope to see you in the next one. Bye for now.